Okay, we're continuing section 6.3 today, and today we're going to focus on radian measure, and the measure of an angle is determined by the amount of rotation from the initial side to the terminal side, so that's something that we already know. We're going to talk about that in terms of radian measure today. Okay, as you know from your activity, 1 radian is the measure of the central angle theta that intercepts an arc S equal in length to the radius R of the circle. So what we need to keep in mind here, okay, let's say we have S is equal to our arc length, okay? All right, so if you look up here at the diagram, S is your arc length. All right, so when that arc length and the radius of the circle are the same, then what we have there is 1 radian. The measure of this angle theta is 1 radian. And so we can take that a little bit further and say that the angle is always going to be equal to S, which is our arc length, divided by our radius. And theta would be measured in radians in that case. The circumference of a circle in radians is going to be 2 pi r. I'm sorry, using radians. If you have the if you have 2 pi, there are 2 pi radians within a circle, but the circumference is going to be your arc length. So there are 2 pi radians around the circumference of a circle, and there are about 6.28 radians in a full circle. So here you have your circle here, and you can see that there are approximately 6.28 radians because this is the length of your radius, and so you've got 1, 2, 3, 4, 5, 6, and then a little bit. And so that's where your 6.28 radians comes in your full circle. And again, that's the angle measure, theta. Now, when we're talking about radians and degrees, we need to understand the relationship between them. 1 radian is approximately 57.28 degrees, and we're talking about the measures of the angles, and it's easier to think about that in degrees since that's what you're used to probably. But let's talk about where that 57.29 comes from. So we know that there are 360 degrees in a circle, and we know that there are 2 pi radians within a circle. If we take the 360 degrees and divide it by the 2 pi, then that's where we get we would get 180 over pi. We simplify that, which is going to simplify to, as a decimal, about 57.29 degrees. All right, and that's when we want to know how many radians there are in 360 degrees. Now, if we take that and look at it the other way around, and we want to know how many radians are in 1 degree, then what we would say, okay, is there are 2 pi radians in a circle divided by 360 degrees. That's going to give us pi over 180. And when I simplify that, I'm going to get this, about 0.017 radians within each degree. Which brings us to converting between radians and degrees. Okay, if you think about how each one of these simplified, meaning here and here, then we're going to use those to convert between radians and degrees. All right, so if you want to convert degrees to radians, you're going to use this here. We're going to multiply the degrees that you have by this value here. And this is just a version of 1, pi over 180. And if we want to take the radians and convert them to degrees, then we multiply by the 180 over pi radians. So just the reciprocal there. And let's look at a couple of examples there. Oh, well, one other thing. Actually, when no units of angular measure are specified, when we're talking about the material in Chapter 6, radian measure is going to be implied in those cases. So now let's do a couple of conversions. Like, let's say we have a 135 degree angle and we want to convert it to radians. what we would do in that case is we're going to multiply by our pi over 180. Okay, and really all we need to do is simplify the 135 over 180 as a fraction, and we would get 3/4 or 3 pi, because we leave our pi there, 3 pi over 4. Okay, again, same process with the 540 degrees. We're going to multiply by pi over 180 because we want to take the degrees and convert it to radians. If we simplify the 540 over 180, that's going to simplify to 3 pi. Okay, and then our last one, we've got a negative angle measure. Still, we multiply by the pi over 180 because we want to convert to radians. Negative 270 divided by the 180 is going to give us negative 1.5, or negative 3 over 2, and then we keep our pi, negative 3 pi over 2. Right? So now let's practice a couple converting from radians to degrees here. In the first one, we've got negative pi over 2 radians. We are going to this time multiply by the 180 over the pi. In this case, in most cases, as long as your radian measure has a pi in it, then the pi's will cancel. And so you're left with a 180 over negative 2, which gives us negative 90 degrees. Okay, and the second one, this one does not have a pi in it, so it's not going to cancel. We want to multiply by the 180 over pi. And when we do that, we get, your calculator, you get about 114.6 degrees. And then on the last one, we have a pi, 9 pi over 2 radians. So the 180 over pi, the pi's cancel again. And so you have 9/2 times the 180. And that is going to give us about 810 degrees. All right. So that brings us to the unit circle. So since we know how to convert between radians and degrees, we could actually go around the unit circle and look at each degree measure. So this is 0. If you start out 0 degrees, 30 degrees, 45, 60, 90, 120, 135, 150, 180, all the way back around to 315, 330, and then 360 degrees. And of course, this can continue past 360 if your rotations occur, more than one rotation. And then also negative if we move clockwise rather than counterclockwise. For each one of these, we have a radian and a degree measure. So like here. And the way if you think about what we've done in the previous exercises, then you can understand why the 30 degrees is equivalent to the pi over 6. If I take the 30-degree angle and I multiply by the pi over 180, then that's going to simplify to pi over 6. And we can do that for every single angle pair that I have here, radian and degree measure. You can convert. So let's just try this one. If you have the 210-degree angle, and I want to convert it to radians, then you can multiply by pi over 180 and simplify that, and you realize that you're going to get 7 pi over 6. Okay. All right, and that's all I have for this part of section 6.3.